Okay, so we want to graph the function h of x is equal to f of x plus g of x, where f of x is inverse to the 2 to the x function and g of x is 1 over x squared. Now, we first construct graphs of these functions. Okay, now the 2 to the x function, well, we know what the graph of that looks like. We just graphed it over here. And the inverse is going to look something like this. Okay? We could label points. You know, this point might be 4, 2. Okay, this point might be 1, 1, 2, 1, 0, and then 2, 1, right? And 4, 2, and so forth. Just inverse to the table that you would have here. And you'd have your 1/4 negative 2, that would be like here, 1/4 negative 2. Okay, well, I assume we know how to construct that graph. Because, yeah, again, on the test, people did reasonably well with that. Would have been better if everybody would have done it correctly, but on the whole, people did reasonably well with it. People that didn't do it, I think, if they follow up a little bit, will know how to do it. Okay? So
now we got to construct.
we got the graph. We need the graph of 1 over x squared. So this is our f of x graph. Now we could construct the entire 1 over x squared graph, and I'm going to do that. I'm going to use colors here. But the 1 over x squared graph, it's going to go through the point 1, 1, which would be here, okay? And it's going to go through the point 2, 1/4, and it's going to go through point 1/2, 4, so it's going to be much like this. And it's going to continue getting closer and closer to the x-axis. And since the x-axis is kind of thick here, it's just going to swallow it up by the time you get out to about here. Okay? So now we want to graph the sum of these functions. Okay? Well, that means we add the values of the functions. Okay? Now, it's going to help if I first make a table, then I'll come back and draw some arrows for the values of these functions and show how they add and show how you can visually see it. But let's go ahead and make tables. So, our f of x function, our x values are going to be 1/4, 1/2, 1, 2, and 4. Our y values are going to be -2, -1, 0, 2, not 0, 1, 2, and 4. Okay?
0, 0, 0.
I was on the right track there. I just kind of, my brain switched, kind of like that unfortunate Amtrak train. Switched onto the wrong track. Yeah, people got killed, so it's no joke. So, but anyhow, at least you know this is a little less harmful. But okay, so there we have it, and then we have our g of x function, where our x values are -2, -1, 0, 1, and 2, and our y values are 1/4.
1, 1/4, 1.
Yeah, I'm wanting to get the 1/2s in there, -1/2, 1/2, okay? And everything up here is going to be irrelevant, incidentally, because I didn't graph the other part of the 1 over x squared function,
Yeah.
because there's no f of x to add it to.
Okay.
So any negative value of x would not be in the domain of this sum. The domain would have to be restricted so that both of these functions are defined, right?
So we'll just be working with the top part of f of x, basically.
Yeah, well,
The even part of f of x.
the only part we'd be working with is the part where we have an f of x, right?
Okay.
Okay, so I made this just a little lighter
Mhm.
because we don't really need it, but it of course is part of the graph of 1 over x squared. Okay, and when I do this, I'm saying, okay, well, these values here,
That's
1/4, 1, and 4 on this side aren't relevant to the sum. Okay, so I kind of put a line here and say, okay, these are all in parentheses because we don't have any x values over here that will match up with these x values,
Okay.
because this function isn't even defined. Okay, but then we have our y values. Well, this is undefined. This is 4, this is 1, this is 1/4, right? So if we want to make a table, and we can do pretty well just by making a table here. So we have x, and then we have y equals h of x, which is f of x plus g of x. We don't bother with these values, but we'll go ahead and use the values here where it's defined. Now, we're not going to use 0 as an x value, okay? Because this function's undefined. We don't have a 1 over x squared function to add to the inverse of this, but then, of course, we don't have a 0 here either, right? Neither function is defined when x equals 0. I kind of said that clumsily, but that's what it comes down to. Okay. Now, this function never gets to 0 because the exponential function
That's why
reaches
that's
0.
why they made it inverse, because you can't use the 0. That's why I was.
Yeah, because of this function never reaching the x-axis, the inverse is never going to reach the y-axis. Okay? Then you have to think through that. So the values that we have here, where we actually have common values of the function, are just where x equals 1 and where x equals 2.
Okay, yeah, 1 and 2.
Now, we might be able to fill in some other values just by estimating, okay? But now, let's look at what we've got. When x equals 1, the f of x is equal to 1 and the g of x is equal to 1, right? So, f of x plus g of x is going to be 2.
You said 1 and 2, so no.
Oh, whoa,
1 is 0.
I'm wrong. F of x is 0.
Yeah.
Keep switching on the wrong track here for some reason. Yeah, there's obvious reasons. Okay, anyhow, when x is 2, then f of x is 1 and g of x is 1/4, right? So when x is 2, we get 1 plus 1/4, 5/4, or if we prefer 1 1/4, right? 1 1/4 might be convenient for graphing it. 5/4 if we want to do arithmetic with it. Okay, so we have 2 points on the graph of the h of x equals f of x plus g of x function. Well, let's see what that might look like. Okay, well, the point x equals 1, y equals 1, well, here's x, here's y. X equals 1, y equals 1, well, that's just right here. Okay? That's the point 1, 1. And of course, it's on the graph of the 1 over x squared function because that's where we got the 1. Okay? We got just a 0 from this one. To add to the 1 that we get for the y value here just gives us 1, the same y value. Okay, so when this function is 0, when we add them, we get just whatever we get for this function. Meaning the point of the graph of the sum is going to be on the graph of this curve. Okay? Now, the point 2, 5 fourths, okay? So, we go out to where x equals 2, and let's just say that we know that 1 is here, and 2 is here. Now, first place, does it make sense that f of x should equal 1 at this point? Well, I drew the graph a little bit too high. If I project up here, it comes out a little bigger than 1, but we'll pretend it's 1, okay? And then this graph, about 1/4, yeah, that's about 1/4 as high as this is, isn't it? So the value of this graph is, this function is this, the graph of this function is 1, okay? Which means that the point on the graph of the sum is going to be this much higher than this, for the same reason that we added 1/4 to the 1 here. And we added the 1/4 to the 1 here because of what the tables told us, right? So the picture tells us the same thing that the tables do. So we add this value to this value, and we get a value up here that's a little higher than this one, when x equals 2. Okay? Now, is there a value where adding the 2 y values that we get from this graph and this graph would give us 0? How could we get 0? Let's think about a couple of these questions. I'm going to turn the camera off for a minute.